Slash Massacees. One word.
All right.
This is mine.
That's it?
Yeah. Should take you there. Okay, let me go grab a shot if they want
Are you
to
going to talk about laser
practice.
campaign or the overlap? Maybe after
Rock level? Oh, yeah.
I can discuss variables as well. I'm going to discuss time, longitude, and latitude. I'm going to add those in just because, like, we also did this. Mr. Transfer. Oh, I love that shot of me. Is this the current longitude? Longitude.
I'll do it.
Hold on, tell me how long it takes. Tell me from now.
For 43, you're gonna show up.
It's still not there?
But yeah, you should be able to open the stream in the YouTube app and it comes up a little bit nicer in the actual YouTube app.
What? Oh, yo, I see it. Okay, it's like a 20-second delay.
Yeah.
That's ridiculous.
I could set it to 30 or a minute if I wanted to, but I can't make it lower than 20.
I guess it's got to process it.
Oh, it just showed up.
It's actually streaming to YouTube right now.
Wow, that must be...
Yeah.
She's not watching it.
Probably
Wait.
not watching. No.
Wait, this is streaming right now?
Yeah.
Nobody's watching it right
That
now.
second side's YouTube.
Yeah, but nobody's watching it.
Yeah,
right
Well,
now.
when we tested it,
I'm
some
watching it.
random person started watching it when we were testing in our dorm. It was weird.
Okay.
That's me,
Go to
20
YouTube.
seconds.
Oh, those
Yeah.
marks on the floor is where you need a stand to be caught by the camera. So if you're talking,
Just like...
Oh, hey, here you guys are. We forgot our
Hey,
things.
you're walking on screen now.
I'm gonna watch on here. I'm gonna have headphones in the back of the room.
I'm so fascinated.
Is it
but then you'd be 20 seconds behind everything they say.
Okay.
Oh, well, set up your stuff on the.
C's.
Oh, let's go.
Well, I don't know
Oh,
where
right.
she
She
was.
was more videos.
Oh, she's getting the stuff.
We're getting the stuff.
I need 1 second, so guys come here.
Oh, did you have the picture that we all took together?
Yeah, I'm about to send it to her.
Okay.
I need your emails and things.
What's the
No,
link or
just
what
look
do I
up NASA C's
Is
YouTube.
lunch at 12?
I'm not on YouTube. Like literally.
So when I'm gonna send you the data,
I'll just
then I will have to put to this
Grab
file
it. Yeah.
that the observer was me,
Do you want to hold it when you're talking?
not
or do
the
you want to-
contact,
That's
Can you hold it?
Yeah.
but
You
the
can do like
measures are
that.
you guys.
Yeah.
Sweet.
So-
We'll do that.
Okay, measure.
Okay,
And
should
I
I make you go in
Oh,
here?
mine's behind.
Chidima, do you want to, if I'm going to
Okay.
demo collect?
Who
you
is
wanna
first?
demo-
Jinima, you're the
I'll just
first one
demo.
in the alphabet, is that right?
Yes.
Yeah.
So, do you appreciate it as C? Give me your name. I don't know how to spell your last name. Can I put
Can
more?
Can I put
So
mine?
it's C or CH?
Time color.
Okay, so I know how you spell it, but the abbreviation is initially C or CH.
How do you say he's watching it?
C.
Can I see the correlation
How do you
between
pick
major
a-
accidents?
Back here, behind the.
H.
Should we take this off?
Run it. Why?
Because
Yeah, okay.
correlation is adaptive.
Next person.
No, don't take it off.
Okay, so it's
Uh,
Alessandro.
You should be able to take out one of the. Are you-
C.
Oh, was there a spot?
Yeah.
When we measure C-search anomaly against transit major C-search anomaly.
Courtney? Okay.
Okay, I should have. You should have just received it on your CSR one.
Okay. You guys want that picture too?
Yes, we want it on this one.
Okay, so who is
Oh,
next?
you posted it.
So it's gonna be C. Duran. Duran. Next person.
Morgan.
M. Duff.
Cherish for the rest of your life.
Is it Nanez or Nanes?
Nanyas.
Nanez. Okay.
No, I told you, I
Brian?
will go up there and take the laser from your hand.
Guys,
Oh, there you are.
Got it.
Wait, can we
Okay.
Oh, it's because this computer doesn't have the fonts probably.
It's the
When we actually do it, just export it as a PDF. Not as a PowerPoint. Yeah, we could just do it, but next time.
Right now though, I'm just, I want to make sure that it can stream for a certain amount of
Okay,
time without
just space.
interruption.
Yeah, and then let's just do it. Let's just do it.
That means we're gonna have it up from 1 to 5, pretty much.
Well, are we gonna stop now?
Export it as a PDF now,
It's
so
just
we
gonna
don't
be
have
one.
any trouble.
I don't
I
want to
can.
send it
We
in.
still need to
Oh, I
add
should,
anything.
right.
How we should just post it.
I need to add it in
Well,
the
don't add
database.
stuff now, though.
I know,
You're
you
adding
do
it.
anything.
Yeah. Okay, so let's just.
Who are you?
All right, almost ready, ladies and gentlemen.
Can I use your printer? Can I use your printer?
Now you have to ask, you can probably print from that.
What do I ask?
Tell me or.
Yes,
Fine.
what's
It doesn't matter
up?
what we
Huh?
Can I use a printer?
Let's just.
What printer did they say?
Dr. Fowler might be able to.
Yeah, Dr. Fowler can probably go.
Or Steve Williams.
Okay.
Okay, so, what you
Yeah,
guys,
because we're gonna, Morgan, we're gonna export it as a PDF next time. It's a PowerPoint now, so the fonts didn't stay. Oh, I thought we were talking about the fonts.
all right, so Tommy, I'll,
Yeah, I should, you should already received it. I sent it like 3-4 minutes ago. The picture of their work,
What's the print? Let's do it.
because they wanted to include it in there.
It's from the theme, but we're gonna fix. Ignore the formatting. The formatting is in progress.
Then they weren't there.
Oh, give me.
Oh, they already.
You wanna-
I thought it was.
Okay, everyone get
Get information.
No, they were doing
1,
it
2,
over
3,
in the
astronomy.
other room.
One of those is on that side.
1, 2.
Oh yeah, but those lines on the floor mark where you're in view of the camera.
Okay.
Wonderful.
all right,
Oh, yeah, you use this in the computer, right?
Okay,
Yes.
perfect.
One of them works, one of them doesn't. There's two.
Okay.
Oh, you did. It's on the table.
Okay, is everybody ready?
No,
Where is
he's
he
getting
going?
his menu. We don't need it. I'm not going there.
did you send it to me, you said?
Yes, I did.
And it's from
Do you want to
Tommy?
chat since you?
Yeah, it should be from
Yeah.
tom.ramirez@gmail.
You come here yet?
No, that just looks funny.
It looks better.
If you
No,
need it
okay.
now, you can literally plug it into the computer and drag it off.
Okay, well, I get Tommy's picture here, is you get something like any of.
Okay, are we now ready?
Do you want the file?
Oh, wait,
we're
do you
gonna
have
put
like
it in
a pointer?
Okay, you can put it in after.
Yeah, it doesn't work.
You can
Okay.
just leave
No,
it
no,
on
no,
when you are
a
talking about
physical
it.
pointer.
Okay, so,
Okay.
Okay, are you ready for this?
yes, let's go for it.
Yeah.
Hi everybody, we are the astronomy team here at the NASA SEAS internship this summer. My name is Morgan Nanez. I live in Austin, Texas, and I'm going to be a senior next year.
Hi, I'm Colette Duran. I'm also going to be a senior at St. Luke's School in New Canaan, Connecticut, and I live in South Salem, New York.
I'm Chinna Magdal. I'm from Los Angeles, and I'm going to be a senior at Norwalk High School.
I'm Alessandro Cartagni, and I'm going to be a junior at Stuyvesant High School in New York City.
Hello, I'm Brian Zinn, and I'm going to be a senior at Lowell High School. I live in San Francisco, California.
The screen, you have to indicate the screen.
One.
Back.
Because astronomy is such a broad topic, during our 2 weeks here in Austin, we focused on astrometry, which is a small section of it, and it combines combines mathematics as well as physics to study our universe. Astronomers catalog astronomical bodies and track them. These catalogs not only help them with keeping track of them, but also when it comes to discovering new astronomical bodies, because the cataloged ones can be used as reference points. And in astrometry, it's very important to be precise, to have precise measurements and accurate data, and data about an object's location within a range of time can be used to take more information about that object's kinematics and its origin.
So the first project that we did here had to deal with parallax. So parallax is the difference in the apparent position of an object viewed along two different lines of sight. So a way that we can all just look at this is everyone, if you put your thumb up, and then everyone, if you put your thumb up, stretch it out. Thank you. Okay, so you close one eye and you see what your thumb is covering, and then you do the other eye, and it looks like the stuff behind your thumb is moving, right? That's because you're looking at it from two different lines of sight because you have two eyes. Okay, perfect. So you measure parallax by the angle between the two reference points, and you have to cut that in half. And even though if it's not like completely straight, or it's not completely in half, because the distances between us and stars are so far away, you can basically just cut it in half. It's practically the same. So the way we use this in astronomy, as you can see on the image in the right, is so say you're on one half of the orbit in January, you calculate the angle from the sun, or the star, to another reference object in space. And then 6 months later on the other side of the orbit, you will do the same thing with the same star and the same reference object. And you will take those two angles, cut them in half to get your parallax.
So, in our 2 weeks here at NASA, we tried to simulate this concept of parallax. Here we have, on one end of the room we had a styrofoam ball mounted on a tripod, and on the other end we had our 2 reference points, as shown right there. We marked them with tape, and at the very far end wall we used that as our reference star. Here we have the math for the parallax motion, and so it tends to get a little bit tedious, so bear with me. We have point A as reference 1, point B as reference 2, and point C as the object we're trying to measure the distance to. So we draw a ray from point A going straight up, and we have this point C, and we measure the angle between ray A and point C to give us angle 1. Then we do the same for point B. We draw a ray and we measure the angle from ray B to point C and designate that as angle 2. Now we then add angles 1 and 2 to get angle C, and that makes sense because of its geometry. Now if we enlarge the triangle A, B, and C, we get the second image over here. This second image, what we did was we dropped a perpendicular line straight down from point C to line segment AB. This directly cuts segment AB in half and also slices angle C in half as well. Now, if we enlarge this triangle right here, ABC, we get this one. Over here, we have a right triangle, ADC, with angle C, or half of angle C, over there. To get the distance, which is what we want, CD, we do the inverse tangent of angle C divided by AD to get the distance.
So in our experiment, our star was this ball here. It's a styrofoam ball, and it was mounted on a tripod. This was about 10 meters away, and so we tried to measure both the distance to it and then later the size of the object. So this was done using the math he explained, and in order to measure the angles involved, we used this protractor here. So we made this using a protractor and some extensions. What this does is it makes a fairly precise measure of the angle, and it allows you to see the angles involved in the parallax. Now this is an improvement on a previous design. The first time we made it, this part here was shorter and this one wasn't present, and because of that it was both less precise in the measuring and also harder to aim properly because it was so out of focus here when you were trying to look at the object, and vice versa. So this allowed it to be both more accurate and precise, and also easy to use. So that's how we got the angles.
Are you going to explain like how to use it if you hold it up and you align it? I don't know. I think it'd be nice. It's okay.
They can use it later.
So our second method for evaluating the angle was something called a cross staff.